Hi, welcome back to Moose in Chemistry. This is redox reaction, oxidation reduction, in a basic solution, problem number 4. All right, let's look at our redox reaction here. The first thing we're going to do is we're going to break our redox reaction into two half reactions. So let's go ahead and look at our first half reaction. We've got Cn negative is going to yield CnO minus. Our second half reaction is going to be CrO4 2 minus yields CrOH 4 minus. Okay, now the next thing we want to do is we want to make sure that all elements other than oxygen and hydrogen are already balanced. So we've got one C here and one C there. See that? Same thing with the N's, one N and one N. So we're good there. So none of that has to be balanced. Let's look at the other half reaction real quickly. On the other half of the reaction, we have one Cr here, one Cr there, 4 oxygens here, and 4 oxygens there. So everything looks good there. So far, so good. Okay. Now the next thing we want to do is we want to balance our oxygens by adding H2O. Alright, well look at this first one here. We have one oxygen on our right side. See that? So that means we're going to put H2O here. So let's look at this oxygen here. We have 4 oxygens on the left and we have 4 oxygens on the right. So our second half reaction is good to go. Okay, so now let's look what we got next here. Put that up there too. Okay. So the next thing we do is we're going to balance our hydrogens. All right, and we're going to add 2 hydrogens to our right side. That's because we have 2 hydrogens on our left side. Let's look at the other half reaction. So we have 4 hydrogens on the right side. So that means we're going to need 4 hydrogens on the left side. Pretty darn snarly, let's say. Okay, so everything is looking really, really good now. Now the next thing we're going to do is we're going to add electrons. So let's go back up here and look at this. This has a -1 charge. The overall charge of this is -1, right? So for this to be a negative charge here on the right side, which we're talking about, our Cn would have to have a value of +1. Why? Because oxygen right there is -2. So 1 minus -2 is going to give us -1. Alright, so now we know what that looks like. So let's go ahead and erase all this here. And we need to know that our Cn is a +1. So that means we're going from a -1 Cn to a +1 Cn. So we are going to be losing electrons. Lose electrons, oxidize, and we're going to lose 2 electrons exactly. Okay? So let's look at our next reaction. Our CrO4, okay, remember that oxygen's a -2, so this would be a -8. For this to be a -2, Cr would have to be a +6, because 6 minus 8 is -2. Okay, so let's clean that side up a little bit, and let's try to keep everything neat here. Okay, on the right side of the equation, let's look at this CR. So OH has an overall charge of -1, but we have 4 of them, so we have -4. For this to be a -1, CR would have to be a +3, because 3 minus 4 is -1, right? All right, so let's go ahead and clean that up again so we don't get things too messy. All right, so what we're going to do is we're going from a +6 to a +3. So that means we're gaining electrons. So gain electrons, reduce. And we're gaining 3 electrons. Oh, pretty cool, huh? So what's the next thing we're going to do? Well, we're going to have to multiply. Since these two are not the same, we have to multiply the opposites. So that what that means is that this equation on top is going to be multiplied by 3, and this equation on the bottom here is going to be multiplied by 2. Okay? So that's really, really important. So let's go ahead and let's do that. Oh, yeah, so we have to put our electrons in here, of course. And on this side, it's going to be a +3 electron. There we go. So now we're going to take care of everything. So what's this going to do is this is going to give us this. It's going to give us 6. The first, well, let's do the top one first. So if we do the top one first, this one right here that we're talking about, let's go ahead and multiply everything together. So this is going to give me 3H2O plus 3Cn negative yields 6 electrons plus 3CnO negative plus 6 hydrogens. Okay, and on the bottom, we're going to get 8 hydrogens plus 6 electrons plus 2CrO4 2 minus yields 2CrOH4 minus. Okay, now what we're going to do next is we're going to cancel out things that are in common as much as possible. So let's go ahead and change our pin color to, like, say, another color like red. And the first thing we're going to do is this. Look, our 6 electrons are going to cancel each other out. Okay? So that's taken care of. Now, look at this. We have 6 hydrogens here and 8 hydrogens there. So that's 6 hydrogens going to cancel out that 8 hydrogens and make that 2 hydrogens there. Okay, so we've canceled out everything that we possibly could. And so now let's write the new equation here. So let's put it all back together. First of all, we want to change our pin color. And now what we're going to do is we're going to put stuff together here. Okay, so we get 2H plus 2CrO4 2 minus forgot to plug H2O there, sorry about that. Add in the 3 H2Os there. My apologies. Plus 3 H2O plus 3Cn yields 3CnO negative plus 2CrO4. Let's make that 4 a little bit better. Sometimes when we try to draw that 4, they turn out looking like 9, so we don't want to confuse the audience. And we're going to make this, of course, it's not CrO4. Come on. Sorry about that. Made a small mistake there. CrOH. Right. See, this stuff can be really complicated if you're not careful. Look. There. Alright, now, the next step we're going to do, since this is a basic solution, we're going to add as many OHs that we need to both sides as there are a total of hydrogens. Alright, so over here, we have a 2OH here. Add to this hydrogen. And on this side over here, let's see how many hydrogens we have. We have 8 hydrogens. So since we put 2OH on the left side, we have to put 2OH on the right side. So I'm a little bit out of room here. So 2OH negative here. So now we're going to take these two guys, this one here, and this one here, combine that to make 2H2O plus 2CrO4. Let me go ahead and fix that again. That 4 keeps messing up on me, but that's okay. That's, we're human, so we need that we make mistakes, and that's all right. 3H2O plus 3Cn negative yields 3CnO minus plus 2CrOH4. Another one of those ugly looking 4s again. It's not been a very good 4 day for me, but we can make these days better, of course. Plus 2OH negative. Alright, you see this 2OHO, this 3H2O? We're going to combine these to make 5 H2Os plus 2CrO4 minus A, much better, plus 3Cn negative yields 3CnO negative plus 2CrOH4. That needs minus sign plus 2OH negative, and that's it. And our equation is balanced. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly. I will see you back here at Musin Chemistry.